Good morning students. I am Nidhi Pagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we started with the electricity chapter and we completed the terms like electric current, electric circuit, potential difference as well as Ohm's law. So in Ohm's law, which is the most important term or important concept in this chapter, Ohm's law states that the potential difference will always indirectly proportional to the current flow, the flow of current. Okay, so let us discuss a lot about Ohm's law and let us discuss regarding the resistance. So we know that according to the Ohm's law, according to the Ohm's law, so we know potential difference was always directly proportional to flow of current unless the temperature remains constant. Okay, then so this can be written as V is equal to R into I, where R is a constant. R is a constant which we can call it as resistance, which here we defined or gave a name as resistance. Okay, so here R can be again calculated by V by I. So this you should keep it in mind. So till now we know the concept. Now let us move to the other thing. For example, let us consider a national highway, or let you consider any road which is a busy road. Okay, so on the roads sometimes the road will be smooth. In between the road you can find the speed breakers. You can find, so you will consider the road, and as well as on the road you can find speed breakers. Okay, now let us consider a circuit. So in the circuit, what all we will be having? Positive and negative terminal of a battery. Okay, so which is connected to a ammeter to see or to measure the flow of current, which is connected to a bulb, and then we have this, and somewhere we will be having the key or a switch. Okay, this is key and this is battery as we know, and this is ammeter, this is bulb, right? So conventionally we will take the flow of current from from positive terminal to negative terminal. So here what happens, guys, as you can see the flow of current over here, the flow of current over here. So the current is flowing in a metal wire. Where current is flowing? It is flowing in a metal wire. Okay. So metal wires are good conductors of electricity. We know that. Okay, they allow the current to pass through them. So these metals, in the ninth standard we learned that these metals will be containing atoms. These metals will be containing atoms as well as some impurities. Okay, we will not get any metal in its purest form. So you will be having some impurities. Atoms and impurities. So here what happens, guys, when there will be a flow of current means I, let me write here, I means nothing but flow of electrons. Will you agree? What is current? It is nothing but the flow or a movement of electrons causes the current. So when electrons or these negative charge particles will be moving, so let us consider this part in a magnified view, in a very big view, in a magnified view when you consider only this part. Okay, so let me consider a metallic wire over here. Okay, this is a metallic wire in a magnified form, and in the metallic wire we will be having the atoms. We will be having the atoms and impurities. So small dots indicates impurities and these are the atoms. And what will be happening over there? There will be a flow of electrons. Electrons will be flowing. Right? So when the electrons will be flowing, they will collide. They will collide with these atoms. They will collide means they will hit these atoms or sometimes the impurities. So this collision or this disturbance in the flowing of electrons, this disturbance in the flowing of current, what it makes? It makes the current to flow. It avoids or it pushes the current. It will not allow the current to flow easily. So that opposing force which will not allow the current to flow easily is called as resistance, guys. I hope the term resistance is clear for you. So here, when an electron hit or collide with the atoms or an impurities present in the metal, the opposition force, the opposition occurs for the flow of current. So such opposition force or opposition is called as resistance. Okay. Now let us define resistance. So by this we can define resistance as, by this we can define resistance as opposition to the flow of current, and it is denoted by, this resistance is denoted by, capital letter R. And in the circuit, if a circuit or a metal wire has certain resistance, so the resistors, what we can call, so those will be diagrammatically labeled as like this. So it shows that a circuit has a resistor. 1 minute. Fine. So like this you can signify or you can show a circuit has a resistor or a resistance. It is denoted by capital letter R. And it is given by, we know that the resistance we can find by a formula, that is R is equal to V by I, where V signifies potential difference, I is nothing but current. Okay, potential difference and current. So by seeing this formula we can say that R is inversely proportional to the current. Inversely proportional means what here? When resistance increases, when R increases, so flow of current decreases. Okay. Similarly, in the other case, okay, if R decreases, resistance decreases, so what happens? Immediately the flow of current increases. So this situation is called as inversely proportional. So always resistance will be inversely proportional to the flow of current. Right? Next. So based on this, we have certain terms to define, certain terms to know before going to the next concept. So let us discuss regarding those terms, guys. Okay. So the terms here are, the first one, conductors. So what are conductors? So from 7th standard we learned regarding the conductors. Conductors are the things which allow the flow of current. But in peculiar or with reference to resistance, how can we define conductors? So conductors here, we can take conductors example as copper wire, the mostly used wire. Okay. Then we can take aluminium. So all the metal wires can conduct the electric current. So these conductors are the things which allow the electric current to pass and which will be having less resistance. The materials which allow electric current to pass through them and will be having will be having less resistance, will be having less resistance. Okay, so this is the definition of conductor. So we can give the metal wires as an example. Metal wires will be a good conductors, that is conductors of electricity. So with reference to or in terms of resistance which have less resistance or low resistance, those are called as conductors, we can see. Suppose now let us consider the other term which is called as resistors. So what are these resistors? We know that in India the total current provided for a home, for one house, is 220 volt. So for one house, consider for my house, I will get a current of 220 volt. From this 220 volt, I am going to connect the current to my electrical appliances. In this 220 volt only, all the electrical appliances in my house will run. So that is, we can say mixer, we can take a fridge, you can take washing machine, then mobile, most important. Then we can take laptop, mobile, fridge, mixer, washing machine, fan, tube light. Okay. So what happens here, from this 220 volt, all the electrical appliances are getting electricity. But the electric current or the electric voltage, the volt of current which is required for mixer, which is required for fridge, for each electrical appliances differs. See, for mobile charge and tube light, I need very less amount of current. So that time, if directly 220 volt of current of that capacity comes to a wire which is attached to a mobile, which is attached to a charger, what will happen to the mobile and the tube light? They will burst out, because due to the high capacity of a current which is not required for these devices. Then what we should do? So in the house we will be having certain things which are called resistors. So you can see the resistors in your house in the main current box. Okay, so those resistors, what they will do? They will control the flow of current. How much ever the grinder needs, that much current will be flown. How much ever fridge needs, that much current will be flown. So these resistance, this term is also important. We can say it opposes current. Why it is important? It is important because it controls the current. We want a controlled current for the devices, right? No doubt we want current. Without that we can't imagine life nowadays, right? But in a controlled manner. So what are resistors? The devices or the materials which opposes, we can say which opposes flow of current, or we can say which controls flow of current. Okay, flow of current are called resistors. Okay, so this is regarding the resistors. Next, so the resistors will be denoted or schematically represented by like this in the circuit diagram. Next, we have the other term called as insulators. So, in the lower classes, we studied that insulators are the things which will not allow the electric current to pass through them. But in terms of resistance, we can define it as which will not allow the current only, means it will be having highest opposition force, means to highest opposition force towards the flow of a current. So that highest opposition force is nothing but resistance. So that we can define as the materials or we can say that substances which have high resistance, high resistance are called insulators. So example, we can take it as plastic, we can take it as rubber, wood. So these all are the examples of insulators. Okay. So these are the terms related to the resistance which are defined in terms of the resistance. Okay. Now, so today we learned what is resistance, how resistor can be represented in a schematic or in a circuit diagram. We also define certain terms. And while performing certain experiments, we know that certain experiments will be done with the help of the electricity. As I said, the voltage of electricity will be more in laboratory or wherever you perform an experiment. So during that period, you want to control the current, flow of current. For that, we will use a device named as rheostat. What is this rheostat? Rheostat is nothing but it is a device which will be connected to a circuit, which controls the resistance. If you want, you can give high resistance. If you want, you can give low resistance. So this is a device which allows to increase or decrease resistance in the circuit. So this is regarding the rheostat. Fine. Next, so what this rheostat will do? This will not affect the main current. Suppose if the main current is 220 volt we will take. So this 220 will not be affected. It will not affect the voltage of a current. Okay, without affecting voltage of the current, it controls the resistance. So such resistance is called as variable resistance. So the next term is variable resistance. So let me write here itself. Yeah, let me write here. So the fifth point is variable resistance. So what is this variable resistance? It is given, or it is by this rheostat. What it does, it controls the flow of current. It controls flow of current without changing voltage, without changing its voltage. Okay, this is regarding variable resistance. Okay, this principle only rheostat will apply. This is regarding today's session. In the next class, we are going to study about the factors affecting the resistance. Which all factors influences the resistance in a circuit. We are going to deal about it. Until that, take care. Have a nice day. Bye-bye.